Good afternoon. My name is Mike Smoyer, President at Digital Government Institute. Thank you for joining us. The topic today is next generation data center storage and virtualization for government. Government agencies operating remote and branch offices are often faced with a difficult choice: provide state-of-the-art computing and data storage solution close to end users, or consolidate to the data center for control and safekeeping. We plan to review an innovative storage solution that can offer government agencies local performance in the branch office, but delivered from the data center. During this presentation, we will cover how to consolidate and protect agency data, reduce storage costs, and improve data recovery. Before we get started, there's just a few quick items to review. First, we will be emailing a link of the archived version of the webinar so you can view it again or share it with a colleague. We will have a question and answer session at the end of the presentation. So at any time during the presentation, if you'd like to submit a question, just look for the Q&A window on the left-hand side of your screen. If you're having any technical difficulties, click on the Help button. That's the file with the question mark located on the lower right-hand side of your screen. Or if you'd like a copy of today's presentation, click on the green file icon on the bottom of your screen. And if you're interested in learning more on this topic, please visit digitalgovernment.com. It's now my pleasure to introduce our panel today. With us is Doug Amdur, Marketing Manager, Merlin; Amir Abbas, Storage Solution Architect with Riverbed; Marty O'Day, Storage Optimization Solutions Executive with IBM; and Michelle Tidwell, Storage Solutions Business Line Manager with IBM. Thank you all for being with us today. We look forward to the next hour. Doug?
Good morning. My name is Doug Amdur, and I am a Marketing Manager at Merlin. Merlin is a provider of comprehensive information technology solutions to the U.S. federal government. What we do is implement technology to solve complex problems by finding, implementing, and customizing technology from companies like IBM and Riverbed. We have unique experience in implementing cybersecurity, network performance management, data storage, and cloud, and enterprise solutions that work. Today's webinar discusses data center consolidation, storage virtualization, and optimization at both the data center and at the edge. Based on their exceptional experience, Merlin is partnering with Riverbed and IBM to implement and manage these solutions that work and are proven in implementations throughout the federal government. I'll now pass it to Michelle Tidwell.
Thank you very much, and good morning, everybody. In today's talk, we're going to cover three main areas. I'm going to be talking a little bit about the partnership that has formed between IBM and Riverbed, and then Amir is going to cover the Granite technology with its features and benefits, and then between myself and Marty O'Day, we're going to talk about what technologies IBM is bringing to the data center to complete the solution. So regarding IBM and Riverbed, we've had a global partnership since 2008, so it's pretty long running, and we've done that across multiple lines of our business, but in 2012, Riverbed introduced a product called Granite, and this provided a new initiative and a new opportunity for IBM and Riverbed to work together. So today we're going to talk about the solution that we've implemented together with Riverbed based on IBM StoreWise family, XIV, and our SAN volume controller, which Marty's going to cover in great detail, together with the Riverbed Granite appliance. So together what you'll see in today's presentation is that IBM and Riverbed improve total cost of ownership for our clients. We've provided optimized solutions to optimize performance, availability, and scalability, and also improve the use and management of data by centralizing these infrastructures in the data center. So with that, let's get started on the details, and I'll pass it over now to Amir.
Thanks, Michelle. Hello, everyone. This is Amir Abbas. I'm a solutions architect with the Riverbed Storage Delivery Business Unit and a technologist with Riverbed. And I want to take the next maybe 15, 20 minutes and talk about our Granite solution. But before I do that, I want to take maybe a couple of minutes and just do a quick station identification of who Riverbed is, what do we do, and how did we come to this solution. So Riverbed is a performance platform solution provider. Basically, we make things faster. So anytime our customers come to us and they want their infrastructure fast, their plumbing fast, their platform, their transactions, or their applications, we have a multitude of solutions that work in concert with each other to give you kind of that best architected solution for your particular application. You may or may not be familiar with our WAN optimization engine called Steelhead. We've led the market share in the WAN optimization market for a number of years now. We've had Steelheads out for quite a few years. We've actually been selling Steelheads for over a decade. And every 6 months or so, we kind of take a poll of our customers just to kind of see how they're doing, how our Steelheads are performing, and what can we do better. And we have about 22,000 customers globally. And the whole purpose behind Steelheads is to start this endeavor of consolidating all the applications back in a centralized location and optimize those applications at layer 4, layer 5 level, and give you the bandwidth and latency reduction to give that user the illusion that that application is still resident in that remote location out there. Well, we started to realize that even with Steelheads, we could not achieve 100% consolidation, or what I like to call consolidation nirvana, which means zero persistent data sitting out there. And when we started asking our customers about why those few lingering services were out there, those applications were out there, well, we started to realize that these services were very locally significant. They were mostly locally accessed services. In some cases, we did not optimize them very well, or no one could optimize certain services, or you did not want them over your WAN, or in some cases, you didn't want any kind of WAN dependency. Perhaps certain remote locations were just not on very robust WAN links. And then so when we looked at that, we came out with kind of a new definition of what consolidation is and a next generation of what our performance platform engine looks like from a branch converged infrastructure perspective, and that's where Granite kind of comes in. So from a consolidation perspective, there's a lot of obviously technical benefits of consolidation, heightened security, better control, better management, lower risk of loss of data. There are also a lot of financial benefits, and as a matter of fact, if we look at it from a CIO's take on it, if they're running IT as a business, what their main concern is how to get kind of the best bang for their buck. How do you get the most value out of your IT investment? Gartner did a research last year, and what they realized that in the data center, the amount of dollar that you spend, you get better yield out of that. So every dollar that you spend, from a value perspective, you get 40 to 60 cents worth of value out of everything that you spend. And we'd like to see that number perhaps even go higher than that. And this can really be attributed to the fact that you have a much higher feature-rich set of toolkits in the data center. You've got enterprise-grade virtualization. You've got much higher feature-rich storage like IBM storage, and so on and so forth. You have much better availability of human resources that are present at that data center location, so you get more value out of it. Conversely, at the branch, we see kind of the exact opposite. We see very low yield for that dollar spent, especially the further that branch moves away or that edge location moves away from the data center. And so usually those branch offices are architected with just kind of the necessity in mind. They're very low feature. They're not very robust, and they're just there kind of as a Band-Aid approach because you're not going to get much value out of it. So it tends to kind of reason that the more you consolidate and the more you can use your IT investment at the data center, the better value you can get out of it. And this is kind of what Granite allows you to do. So if we look at maybe what a typical remote location looks like, it's comprised of a few moving pieces, right? So if you look at kind of the top right corner of this slide, we've got servers, some storage associated with that server, whether it's directly attached storage or an external storage shelf. And then the fact that you have some data, some persistent disk out there, you have to now protect that data, so you have some backup solution with tape. And all these moving pieces require a lot of management, support, and administration, so all those operational costs that kind of come along with that. So what we're trying to do with Granite is take all of the moving pieces out of the branch, put them back at the data center, reutilize the investments at the data center, project them back out to the edge for only what is required. So we do that by removing and consolidating all of the persistent storage that's out there and bringing it back to the data center. And since there is no more persistent disk at the data center, there's no reason to protect it at the branch. All of the data protection, the backups and recovery is all done at the data center as well. And lastly, we've partnered with VMware to give you kind of that enterprise-grade virtualization hypervisor engine built within the Granite appliance at the edge for all the services that you need locally computed and executed out there where you don't want to be dependent upon WAN, where you want true LAN performance. So we can give that to by reducing the footprint and changing the landscape out there. So where previously you had storage and servers and backups and administration out there, now that you're starting to take some of these pieces back and put it in a very small form factor that's managed completely remotely, and it's very, very easy and fast to provision and recover, more importantly, all the administration costs that goes with those pieces completely goes away too. And lastly, what we're really trying to do is get the more value out of the IT investment at the data center. So if you've invested in, for example, IBM storage, not only do you want to use those storage features in the data center, but you'd like to extend that feature functionality out to the edge. Now we can do that by extending or projecting those services and applications by means of Granite out there, and using features like thin provisioning or snapshotting and cloning, template-based provisioning, or even deduplication across all of your branches to kind of raise that value from maybe 60 cents worth of value per dollar to maybe even 70 cents. So that's kind of the high-level business value proposition of what we're trying to do. I want to get into maybe how we do it, which is more probably interesting to this audience. So this picture kind of shows a very crude depiction of what an enterprise network may look like from a single data center and a single remote location perspective. So on the left-hand side, we've got this branch office or a remote location, and it's got a bunch of servers and some users and maybe some storage associated with it. And it's also got some backups, right, which I'm not showing. On the right-hand side, you've got the data center, which has similar solutions, albeit much more feature-rich, and you have better human resources out there. So you have a much more feature-rich storage, you have enterprise-grade virtualization, and everything back at the data center. Granite is comprised of three functional components, so within a single box. So we've got the underlying component of a steelhead WAN optimization, and what that allows us to do is take some of these services out of the branch, bring them back to the data center where they can be managed and configured and provisioned and recovered, and optimize them at the application layer to give you bandwidth and latency reduction so that an application to the user may appear that it's still sitting fairly close to him. It's everything to the left-hand side of that branch steelhead is what we started focusing on beyond steelheads, and we said, what can we do to even consolidate those services? So we've already established that there's a reason why these services are locally resident. They're mostly locally accessed. They're locally significant, and we don't want to be WAN dependent. So we partnered with VMware and created a service called VSP, which stands for Virtual Services Platform. It's nothing more than just a basic ESX hypervisor running on our platform. And now we can consolidate or run all of these remaining services out there on top of this steelhead. Now, this is very similar to, if you guys are maybe familiar with some of our legacy offerings with RSP, which was Riverbed Services Platform, where you could run certain number of services locally within the steelhead. Where Granite really comes in is it takes all the storage associated with those VMs, including the VMD case for all of the OS drives, all of the files that are associated with the file servers, every bit of persistent disk, brings them back, puts them on a much feature-rich, much enterprise-grade storage in the back end, and using Granite projects out only the storage that we need to make that branch function at any given instant. So what we're really trying to achieve is what we call a stateless branch, which means there's nothing persistent in that branch. That branch could disappear off the face of the earth, and you're not going to lose any data because it's just running off of some cached service out there. And only the services that are locally required are running on top of that steelhead. So another way of looking at it is that Granite decouples the compute component of a server from its disk over very, very large distances. Right? So where in the data center you've already invested in storage, you've already invested in virtualization, and you would like to extend that out to the edge, Granite brings back, I know our marketing uses the moniker of that it's kind of like a vacuum cleaner. It sucks back all the bits and bytes and all the persistent disk back to the data center for better management, better control, better security, and projects only the VMs that you need running locally out at that edge, thereby extending that virtualization all the way out to the edge. So where previously consolidation and performance were kind of inversely proportional to each other. The more you started to consolidate applications, the more you were going to hinder performance to the end user. Now we've kind of decoupled that relationship too. Now you can achieve 100% consolidation on a much better disk, but still, would still give your users LAN performance, LAN speed performance that they were used to. So we want to bring the disk back because that's where all our administrators are. That's where you'll manage everything. That's where you'll back up everything. But we want to leave the compute out at the edge because that's what the users are interacting with. So if it's a file server, they're going to a compute resource of that particular file server. One of the benefits that Granite provides you is the centralized administration piece. And it really kind of comes into play when we're talking about the non-sunny day scenario. So when you provision a new application or a new service, or maybe more importantly, when you recover a down service, right? So Granite consists of two components. You have a Granite core appliance, and that could be a physical or a virtual appliance that sits in the data center that talks to your storage. And then there's a Granite edge appliance that sits in the remote location that constitutes those three functional entities: Steelhead WAN op, we have VSP with the ESX hypervisor, and the Granite Edge cache. All of the provisioning and sysprep and everything is done, everything is staged at the data center, and you simply project it out and push play at the edge. Now, at a high level, this may appear very similar to maybe a storage solution, right? So for example, a big NetApp at the data center and maybe an ONTAP at the edge, and we're just doing replication between the two. What makes this different is the fact that we have this Granite core entity in the data center that's not only just doing the management piece or the storage projection piece, but it's also acting as sort of a witness capacity. So it's monitoring what each of the branches are doing. So what I mean by that is, let's say in a NetApp world, let's say we're provisioning a server, and it's a file server, let's say it's a Windows file server, and that's about a 50 gig VMDK file, let's say a virtual file. In a distributed model, you'd have to somehow send that 50 gig across the WAN or ship it overnight or something to that location before you can even boot that server up. In a Granite world, you can project that 50 gig data partition out without copying anything. When you push play at the edge, Granite has these prediction and prefetch algorithms built in, Granite Core does. So when it's monitoring and kind of witnessing what the edges is doing, it can realize that you're trying to boot a Windows server from a certain data partition on your backend storage. So instead of sending you the entire 50 gigs worth of virtual disk, it's going to parse that 50 gig and only send you the files and folders that you need to get a Windows server started and all the necessary services going, which ends up being about 300 megs. So its file system awareness gives you the capability to really provision and recover stuff much, much faster. Right, so I just did a POC for a customer last week, and we had the Granite Core in Nashville. We had a Granite Edge in Ann Arbor. It was about an 80 millisecond latency between the two sites, and it was a dual T1 circuit, so about a 3 meg pipe. And we were able to boot a Windows VM over the WAN in about 7.5 minutes. Now we're just talking about the first time you're accessing a file. So this was a cold, brand new Granite Edge. As Granite starts to learn what the access patterns are, it starts to cache those data blocks within the Granite Edge cache, and the subsequent requests for those blocks are all local. So the first time I booted that server was about 7.5 minutes. The subsequent boots of that server was about 1.5 minutes because now all of that data that requires to boot a Windows VM is now cached locally on the Granite Edge appliance and gives that user the LAN speed that we were talking about. Another way of looking at it is really in terms of RPO and RTO. So if we look at any branch converged infrastructure that's out there, maybe SimpliVity and those types of servers that gives you storage and networking, even FlexPod or vPlex. When we look at that, what differentiates us from those services is we give you consolidation, which means better data protection, better business continuity, without any administration that's local to that particular site. And in order to really kind of see that maybe visually, if we look at a kind of a timeline of what a server goes through, and specifically a branch server, because that's where these phases really kind of come into play, there's really three things that server goes through. First, you provision that server. And then when it's up, you protect it or you back it up somehow, maybe nightly backups or something like that. And then that server goes down and then you recover it. And then this process kind of repeats over time and until infinity. So there's really these three distinct phases or stages that every server goes through, and they're really more pertinent when we're talking about a remote server where these get affected to the administrators a lot. And if we look at the amount of administration is needed on these three phases, I would say that the outer two phases are probably going to be the more high touch, right? The recovery being the most high touch, but even the provisioning requires a little bit more manual intervention. And then the protect phase in the middle is probably the least interactive. And if we look at it from just a server being up or a server being down on the y-axis, it's going to take you some amount of time to provision that server. Then that server is going to stay up. And then it's going to take you some amount of time to recover that server when it goes down. And then that graph kind of repeats itself, right? So, and then while it's up, you're probably doing some sort of a data protection on top of that server in case it goes down, right? So most of my customers are doing nightly incrementals and maybe weekly fulls. So every midnight you take a backup of that particular server. And one of the things you notice is the top horizontal line is probably represented by the availability of that server, right? So analysts measure that in numbers of nines, right? And you always get better availability or higher availability at the data center than you do at the edge, because when that server goes down, usually without warning, that's going to take you a lot of resources and software and hardware and human resources to bring that server back up. So if we look at some of the kind of the variables of what affects us, so this is how long it takes us to kind of provision it, so I just called it time to provision. But what's probably more important is our recovery time objective. How long does it take to bring that up, which market research shows it's anywhere from 24 hours to 72 hours or even longer in some cases. So 2 to 4 days sometimes or longer. That's your typical RTO at a remote location without any administrative presence. And then your RPO typically is about 24 hours, so which means that when that server went down, the amount of data loss was this much in terms of even when you recovered that server didn't come up in its fully healthy state. It was degraded based on the fact that that was recovered on that last nightly backup that you took. It is our belief that Granite makes all of these three phases better for you without any administration. And what I mean by that is we can provision a server much, much quicker because everything is provisioned in the back end and you're simply pushing play at the edge and you're booting these servers over the WAN. But more importantly, we can recover a server much faster. So even if you were to lose that Granite edge, that's just a cache. That's just an imitation of that server. That can go down. You simply have to replace the hardware, project the same storage that's back in the data center out to that new Granite edge, push play, and within minutes you've got that server back up and running. And while the server is up, the way Granite works is because you're constantly reading and writing to that Granite edge cache, we're continuously protecting that data. So anytime a user writes something at that, so let's say there's a file server that's executed at that Granite edge, and the user is reading from it and writing from it, anytime a user writes something to it, those changes, the change blocks, are continuously and asynchronously sent back over the WAN. So we're not waiting on some sort of a scheduled replication to, like a 24-hour type of a replication to bring it back. So in this picture now, we've got much better RTOs and time to provision, and we also have much, much better RPOs. So the RTOs and the time to provision, if you look at the horizontal line at the top, is now a lot longer, hence your business continuity is a lot longer. Your amount of availability of that service or that application is much, much higher at the branch even, due to the fact that we've got these prediction and prefetching algorithms built in that makes those outside stages much, much faster. But also your data protection is much better because we're continuously protecting that data and bringing it back. So instead of a 24-hour delay, we may only be a few seconds or a few minutes behind. So the amount of data that you're going to lose is going to be a lot less. And on top of that, all of the tools that are used to manage this entire solution are back in the data center. Your IBM storage is back at the data center. That's managed through a single pane of administration. Your VMware is managed through vCenter or so back at the data center. And all of the Granite management, all the projecting and everything is also done on the Granite core piece, which is also back at the data center. So just to kind of give you where we are, how long ago has this been around, the Granite is a kind of a homegrown, done through our own research and development project, and it's been out GA for 2 years. We're just about to release our 3.x code, so it's fairly mature. We have over 120 customers, including federal and DoD, and there's in all sorts of verticals. And I work on the commercial side, so I'm more familiar with that aspect of it. And there are customers that are using it for, besides the value propositions that I shared with you, they've found their own ways to kind of use this. So we have a large entertainment company out of Anaheim that's using it for more compliance purposes. So they've got these large media files that they want to ship out to remote edge locations where they don't want to keep them out there, especially in countries like China. So they've got these Granite Edge caches out there that they can pre-populate ahead of time, and they can, with a push of one button, they can completely wipe down that cache if something was going on. So they wanted more security and more control over that. Construction company that I worked with, actually out of Wyoming, they had these non-stationary branches. So these were trailers that they were doing a lot of CAD work on, and CAD files, especially large ones, don't work well over the WAN, even with WAN optimization. So now they have this 1U appliance in the trailer going over a VSAT link that they can pre-populate all these CAD files and utilize them and use them locally. And with Granite, they can push all the change blocks back and have everything protected back at the data center. Another company I worked with in the oil and gas firm, they had a large number of very small branches, but even with small branches, they needed to protect the data that was out there. So they had local backups, tape backups at every single branch, and it was very cost prohibitive for them to do local backups. So their main ROI from their perspective was bringing all the data, all their primary data from each of the branch back to the data center using Granite, and then using our Whitewater solution to retain that data locally and deduplicate it on a Whitewater appliance, and then pushing it out to the cloud for backup and archival purposes, which is also deduplicated, so you could store petabytes worth of data and only pay terabytes worth of cost to the cloud. So those are some of the ways our customers are using this. I'm going to pass it back to Michelle, or do I take questions now? I couldn't remember. I'm sorry.
I'll take it next. Thanks a lot, Amir. And I'm going to talk about what is happening at the data center with my colleague here, Marty O'Day. And we've got, technology that will really help on the data center side in terms of control management, backup recovery, and cost. When we discuss these 4 different elements, it's together with the Granite technology at the edge, we bring certain technologies and features in the storage that's at the data center that completes the picture. Because if you don't have good technology in the data center to address these 4 areas, then what's happening at the edge isn't going to be as productive. So if we move into what we're doing in the data center, it's about consolidating and centralizing the management, the protection of that data. And there are 3 elements that we're going to be discussing here. Storage virtualization, which is managing storage in a heterogeneous data center. The product that we'll be covering to talk about that is the StorWise family, and in particular SAN volume controller. Also saving costs. So there are advanced storage capabilities that are brought forward, such as FIM provisioning, compression, easy tier management. We're going to go into some of those to show you how by implementing these technologies in the data center, you're actually doing more with less. And then, of course, protecting your data, achieving those RPO, RTO times that Amir talked about also involves how you protect that data in the data center to make it available to the edge. So technology that we have in terms of centralized and instant copy and remote replication is all part of that story that we're going to be covering. Just to give you an overview from IBM's perspective of storage, we have a very broad portfolio, and we're not going to be talking about all the products in our portfolio today, but we're going to focus on the ones that you see circled here on the chart because these are the ones that we've really focused on with Riverbed Granite and certified with Granite. If you start on the left, these are technologies that really add value to our smarter storage. They make our storage smarter, if you could say. And storage virtualization is the top thing, SAN volume controller being the product. We're going to be talking about that later. And then also our real-time compression capabilities that are introduced and embedded in our solutions. In terms of the actual disk arrays, we'll be covering XIV, which is at our enterprise level for Tier 1 storage. And then we have our StorWise family. StorWise V7000 is our mid-range product. And also tape and virtual tape systems are available for backup and archiving capability. And over on the right, Tivoli Storage Manager from IBM is a software product that can be used to control and manage your backups. Going into a little bit more detail here, IBM and Riverbed have developed three main solutions for the edge to data center storage consolidation. First of all, the StorWise V7000, that would be targeted toward medium-sized businesses, clients that have substantial amounts of storage but are not growing to the capacity of an enterprise-level business. We have SAN volume controller, which is meant for heterogeneous environments where customers have multiple types of storage in their data center. It could be NetApp, Hitachi, all the main brands that you can consider. There are over 100 different storage controllers that can be virtualized behind SAN volume controller. And then we have XIV at the high end. So for small and medium businesses, StorWise V7000, SAN volume controller, and XIV for enterprise class data centers. You can see in the graphic here the attachment. This is really based on the graphics that Amir showed earlier where we have Granite at the edge, and then in the data center we have Granite Core with the different products that can be attached behind it. So when we talk about lowering cost, we're going to spend quite some time talking about the StorWise family and the features that are offered by StorWise. And those features are a natural fit to get better economics from the storage that you have in the data center. Clients can actually buy less storage and get more functionality through the features that are mentioned on the right side of this slide. For example, storing 5 times more data in the same space with real-time compression is a real benefit to clients, so they don't have the footprint expanding at the rapid pace that some other systems require. In fact, we can have up to 80% less space needed with real-time compression technology. Also, performance. Performance can be increased by up to 3 times by installing just 5% solid-state disks and using them with IBM Easy Tier. This is a technology that places only the most I/O-intensive parts of the data on the solid-state disk. We can save labor time with very, very easy-to-use graphical user interfaces and lowering storage growth by 30% due to these better efficiencies and features. So there are a lot of elements of the technology that can be brought forward, And I'm going to pass the baton over now to my colleague Marty to take us through some of those details.
Thank you, Michelle. This is Marty O'Day. I work in IBM Federal Storage Group focusing on storage optimization solutions, and we're going to spend the last few minutes of the call today talking about what IBM does with virtual storage solutions, including software-defined storage. As Amir mentioned earlier in the presentation, management is becoming a larger and larger component of IT costs for our customers. 15 years ago, roughly 30% of the IT dollar went to management and 70% went to the actual purchase of the hardware infrastructure. Today, those numbers are reversed. Over 70% of the IT budget goes to management, and 30% or less in some cases goes to purchasing and refreshing that hardware. So the idea of the IBM Storage Optimization Suite in conjunction with Riverbed Granite is to help you make the most of your IT infrastructure, maximize usage of what you already have, and make it easier for your storage administrators to use. So what we see happening in the storage space is similar to what happened in the server space over the last 5 years or so with the advent of server virtualization. So what a product like VMware or Xen or Hyper-V might do for the server space, IBM Storage Optimization Solutions do for the storage space. We enable you to take, in many cases, a mix of storage from multiple vendors, an EMC, a NetApp, IBM, Hitachi, and many others, and treat them as a single pool of tiered optimized storage. And what that does is lets us maximize the effectiveness and usefulness of resources we already have, as well as minimize the burden on our storage administrators. So by virtualizing our storage infrastructure, we now have one pool of capacity that we can allocate based on the way we need to use it or the way our business is run, rather than based on where the capacity is located or where the device drivers are loaded. So rather than having an island of capacity in an IBM subsystem that I can't use with an HP server because the HP server doesn't have the right device drivers, in a virtual storage environment, I can allocate capacity the way I need it through one easy-to-use interface, regardless of where that capacity lives and regardless of what server needs to use it. All storage in a virtualized environment has the same characteristics, regardless of vendor or class of storage. So even if a subsystem I virtualize doesn't have thin provisioning capability, for instance, my virtualization layer has that capability, and anything behind it inherits that. The same with automatic tiering. Michelle mentioned compression. We'll look at that. Basically, I get identical function across any storage on the back end, regardless of vendor, by virtualizing it. I also get the ability to move volumes among storage subsystems or among classes of storage, either manually or automatically if I choose to. So if I have capacity on a high-end system that's not being used and I need new space up there for a new application, I can dynamically move that workload down to a Tier 2 system, for example, and free up capacity on that high-end system. One of the challenges we address with our virtual storage solutions is management. So we give you the data to make intelligent decisions about what to move and when to move it, and the option to let the system move it for you based on data that it collects. All of this is centrally managed through a common graphical user interface. So as soon as the storage is virtualized, I don't have to go back to the back-end system to do anything to it. I can initiate instant copies or remote copies. I can move data. I can create and expand runs, all through the virtual storage layer. So very powerful for storage administrators and for users. And because I see storage as an enterprise resource, I can also tell who's using it, how much they're using it, and I can help users understand their impact on the budget. So a very powerful way to manage storage in the enterprise, and with a solution like Granite, extend those same benefits out to the edge as well. So what kind of functions do we bring to the storage space in our virtual solution? We mentioned thin provisioning, the ability to only take up space when customers are actually using it, the ability to allocate 500 gig to a database, but maybe the database isn't using all that space, They may only take up 100 gig of space on the back-end box. And again, anything that's virtualized with an IBM storage optimization solution inherits that function. You don't have to license it to the back-end box. You just have to virtualize it. You pick up that function. Automated storage tiering is a key function in enterprise data centers today. Our storage optimization solution implements that as well. The ability to mix capacity from an existing system with solid-state capacity from a purpose-built appliance and have the system automatically determine what workloads go onto that solid state based on utilization rates. So you don't have to pick what goes onto solid state. The system is going to watch the workloads. It's going to dynamically move small portions of the workload around onto the solid state for those that will get the most benefit. In addition, we bring a tool called Storage Analytics Engine, which lets you look at all the storage in the enterprise and determine how well it's placed, whether the Tier 1 workloads are actually taking advantage of the Tier 1 function or whether they could be moved down to Tier 2, whether there are workloads in Tier 2 that are stressing the Tier 2 response times. Should we move those up to Tier 1? And you can collect the data, analyze it, and make decisions, or you can enable the system to make decisions automatically. And this is for IBM and non-IBM storage, for existing storage, new storage. Part of the beauty of IBM's approach to storage optimization is we bring all the function to the optimization layer, but we don't require you to rip and replace your existing storage to begin to take advantage of it. Other functions we provide in the optimization layer is remote clusters and mirroring. So if you have disaster recovery requirements or workload balancing requirements among data centers, we can handle that at the virtual layer. We have integrated snapshot management. So as you need to do instant copies for backup, for archive, for testing, we have application integration with tools like Oracle, DB2, SQL Server, Exchange. So again, without going outside the virtualization layer, I can do everything I need to do to manage my data center and make my environment more efficient and effective. We're also cloud ready, so any storage that you virtualize, regardless of whether it's cloud ready or not, becomes accessible to cloud applications through things like the RESTful API simply by virtualizing it. Key capability IBM brings to the storage space that is unique in the industry is IBM's real-time compression product. Now, many vendors offer compression solutions. Some of them compress in batch mode. The data is written full size. If I have a 100 gig file, I write 100 gig. I come back and I compress it in the background. You have to have spare cycles to do that. You have to have space to catch that data initially. IBM's approach is real time. In other words, we write the data immediately compressed. So if I have a 100 gig file, it compresses down to 25 gig. All the space I need on the back end is 25 gig, both for initial write and for updates as well. What are the kinds of savings we see with typical applications? Databases like Oracle and DB2, 4, even 5 to 1. Exchange servers for email, 2 to 1. Virtual servers like VMware, typically 3.5 to 4 to 1. And text files, sometimes as high as 10 to 1. Now, the unique value proposition here, though, with real-time compression is not the compression piece. There's many ways to get compressed data. It's the fact that IBM can do this compression real-time, in line, for both initial write and for update. The graph on the left of the slide shows workloads on Oracle and DB2 databases running virtually identical with uncompressed disk and compressed disk using real-time compression. And on the right-hand side of that slide, the jet stress benchmark actually shows better performance with a compressed workload. And you say, well, how could that possibly be? If I'm doing compression in line, how can I get better performance? Typically, the slowest part of a storage equation is the disk on the back end. So I still have mechanical. It's the only mechanical device left in the data center for production storage. And with real-time compression, if I can do half or a quarter of the reads off that mechanical device, I can gain speed there. If I'm using IBM storage optimization to virtualize a subsystem that has 16 gig of cache today, and I'm getting 4-to-1 compression, that 16 gig of cache in the system I'm virtualizing looks like 64 gig of cache to my applications. So I can actually make the existing infrastructure more efficient and effective and deliver more usable space, potentially reclaiming up to 80% of existing data center space just by virtualizing with an IBM storage optimization solution. So, and then with a solution like Riverbed Granite, we can extend those same benefits out to the edge with no additional management at the remote site, no additional intervention. We can handle it all from the data center, virtualize the existing infrastructure, and see benefits not only in the data center itself, but also in any edge location connected through the Granite appliance. So with that, a brief overview of IBM storage optimization solutions. I'll turn it back to Michelle for a summary.
Marty. So today we've covered a number of points about our combined solution between Riverbed and IBM, and hopefully you've been able to see how together IBM and Riverbed improve the use and management of data through improving efficiency at the edge with Riverbed Granite technology, reducing storage costs through IBM smarter storage technologies, being able to virtualize heterogeneous storage in the data center through SAN volume controller, and providing centralized backup and protection in the data center instead of at each edge location. We have a number of materials available for you if you care to look at those, including a couple different white papers that IBM and Riverbed have developed together on how to deploy these solutions with both the StoreWise family and XIV for the enterprise, as well as a solution brief that summarizes the solution. So thank you for your attention, and I'm going to turn it back over to Mike.
Thank you, Michelle. Before we begin the Q&A session, I wanted to remind everyone we will be sending an archived version of the webinar within the next day or so, and we did get a question about getting a copy of the presentation. If you just look on the bottom of your screen, there's a green file icon. If you click on that, you can get a copy of the presentation. Okay, I'm going to take executive privilege here for DGI, and Michelle, Marty, or Amir, I think each of you used the term the edge. And just for the benefit of the audience, can you give a definition of what you mean by the edge? Michelle?
Okay, I'll start. Either Amir or I could answer, but we're talking about branch offices for businesses that have a centralized data center, perhaps where they keep most of their servers and storage and backups. They may have branch locations or edge offices as well, where they have maybe a smaller number of employees and smaller amount of storage and compute. So that's what we mean by the edge.
Okay. Amir, I'm going to direct this next question to you.
Sure.
What sets this apart from others currently available in the marketplace?
So fundamentally, it's a different approach of doing branch converged infrastructure. So majority of the solutions that are out there, a few of them like I mentioned, Nutanix or FlexPod and SimpliVity, they simply change kind of the footprint of what's there. So instead of having a 7U or a 10U requirement for networking and for server compute and for storage, they give you all of that in a 2U, 3U, 4U type of a solution, and they give you some sort of a management type of an API. What I like to call those solutions is kind of the outside-in approach, which means that those solutions are still autonomously and independently placed at each location, and they still possess persistent disk out there. And then you bring that disk back to using some sort of a replication solution back to the data center. Granite is the inside-out approach where we want to start from the data center and then project the data and the feature set back out. And it also allows you to use existing and investments that you've done with your partnerships, for example, with IBM and with VMware and with other perhaps backup solution vendors like TSM, and be able to use that all the way out at the edge without having to purchase them at the edge or without having to manage them at the edge. So that's kind of the philosophical or the fundamental difference between the distributed versus the consolidated approach that Granite provides. And the minimum footprint that we can give you, and the only reason really the Granite Edge exists is to kind of satisfy the laws of physics, right? So in some cases, for some applications, the speed of light is too slow. So if those applications are executed locally close to the user at the edge, so to speak, then we can kind of give them that local LAN performance that they're used to.
Michelle or Marty, do you have anything to add?
Well,
Otherwise,
I think it's important when you look at a solution that you want to look at the complete range of issues that you're wanting to solve, and it's important to find a full-featured solution. And I think with IBM's storage optimization technologies, we deliver that. In other words, we give you all the functions you'd expect in the enterprise in the optimization layer, as opposed to requiring secondary solutions or other appliances to deliver things like flash copy or remote copy or tiering. So much like Granite delivers a complete solution for working with remote sites and branch offices, IBM Storage Optimization Solutions and standalone solutions like XIB deliver a complete solution for the data center.
Okay, since we're coming up to the top of the hour here, I'll make this the last question, and I'm going to throw it out to you, Michelle.
Okay.
How battle-tested is this solution, and can you elaborate?
Okay, yes. We have done extensive testing of the solution with Riverbed. In fact, earlier this year, we had a complete test plan put in place and executed at our IBM Competency Center out here in Silicon Valley in California, where IBM engineers and Riverbed engineers came together. All the components were set up in the lab. The protocols were tested between the Granite appliance and SAN volume controller, StoreWise V7000, and XIV. And that is actually what is documented in these white papers that the links are provided for, and it's a step-by-step process on how that setup went and how to make it work. So it's very, very fully tested.
Wonderful. On behalf of Digital Government Institute, I wanted to thank Michelle, Marty, and Amir for taking your time to join us today to talk about the next generation data center storage and virtualization for government. We very much appreciate your participation, and we also like to thank Merlin for sponsoring today's webinar. Thank you. On behalf of the audience out there, thank you very much for tuning in and all the support you provided to Digital Government Institute over this past year. So on behalf of the Digital Government Institute team, this concludes today's webinar. Have a great day, everyone.